Today we're going to look at standard A.10E, which says the student is expected to factor, if possible, trinomials with real factors in the form ax squared plus bx plus c, including perfect square trinomials of degree 2. First, I'd like to share some information that comes from TEA. This information comes from the Mathematics TEAC Support and Information document for Algebra 1. In that document, it says that students may be presented with a trinomial that cannot be factored. Students may be expected to factor the greatest common factor from a polynomial, and students may be expected to factor perfect square trinomials. So some strategies or a process to help when factoring trinomials is, first, you want to rewrite the trinomial if necessary. It needs to be in descending order by degree, so if it's not in that order, you need to rewrite it. Then after that, you want to first check for a greatest common factor and factor that out if there is one. Next, you want to check to see if it's a perfect square trinomial. If it is, then you want to factor that perfect square trinomial. Then, after that, if it's not a perfect square trinomial, you want to determine if the trinomial is factorable or not. If it's not factorable, it's referred to as prime. When you're factoring trinomials with a leading coefficient 1, you can use factor tables or the box method. When the trinomial has a leading coefficient other than 1, you can use box method, grouping, or a method called multiplication division. Sometimes people refer to it as a bottoms-up method. So let's look at this example. If possible, factor the expression 2x squared plus 7x plus 4. Well, it is already written in the correct order, so we do not have to rewrite it. There is no greatest common factor here to factor out. It is not a perfect square trinomial, so now we're going to look at it and determine if it can be factored. So a strategy to do that is to create a factor table. So I'm going to create a factor table, which is going to show me factors of positive 8, and then the sum of those factors. Now the reason why I'm listing the factors of positive 8 is because when you have a trinomial with a leading coefficient, you take the term in front of that leading coefficient and you multiply that times the last term. So we multiply 2 times 4, which gives us a positive 8, which is why we're going to list the factors of 8. So let's start listing these factors. Well, I know 1 times 8 will give me 8. I know 2 times 4 will also give me 8. Negative 1 times negative 8 will also give me a positive 8. And negative 2 times negative 4 will also give me positive 8. And those are all the factors for positive 8. So now we're going to list the sum of these factors. So what is the sum of 1 and 8? Well, 1 plus 8 would be 9. The sum of 2 and 4, 2 plus 4 would be 6. The sum of negative 1 and negative 8, that would be negative 9. And the sum of negative 2 and negative 4, that would be negative 6. So now what we're looking for is for the sum of the factors to be equal to the middle term and give us a value of 7. Well, none of the sums are equal to 7. Therefore, this is a prime trinomial, or it cannot be factored. There are no factors of 8 that will add to give a sum of 7. Therefore, the polynomial cannot be factored and is